Okay, so last video we had Euler. In this video we have L'Hopital. So this is L'Hopital's rule. Okay, so where L'Hopital's rule comes up is that if you're taking the limit of some sort of ratio as x approaches c of some f of x over g of x, and you either get 0 over 0 or you get positive or negative infinity over infinity. These are what we call indeterminate forms because we don't know if they should be going close to 1 or they should be going close to infinity. So we have no clue as to what these things are going to. But if this is actually happening and you get one of these two indeterminate forms, then according to L'Hopital, what I can do is I can replace the limit of the ratio of the functions with their derivatives. So the limit as x approaches c of f of x over g of x, only when you have an indeterminate form, will become the limit as x approaches c of f prime of x over g prime of x, which makes resolving these limits really, really easy. Now, another note here is you cannot do this unless you get one of the indeterminate forms, because if you try to do this without one of the indeterminate forms, you're going to get the wrong answer. The other thing is that c, in this case, you can have limits as x go to infinity or negative infinity, and this still works. And you can also use one-sided limits. So this will also work if I'm taking the limit as x approaches c from the positive side or the negative side as well. So those work as well. Okay, so one-sided limits will work. All right, so let's give an example of this and then we'll move forward. Okay, so we have, let's take the limit as x approaches infinity of the natural log of x over x minus 1. Now, if we kind of think this through, we know that the natural log has a slow growth rate, and it's slower than the linear growth rate, so this thing should dead to rights go to 0, but we can use L'Hopital's to prove that as well. So if we do this straight up and I try to take this at face value, as the natural log of x is going to infinity, it's going there slowly, but it is going to, the natural log is also going to go to infinity. So my numerator is infinity. X minus 1 is going to go to infinity as x is going to infinity. So I get the indeterminate form, infinity over infinity. So according to L'Hopital, this can be changed into the limit as x approaches infinity. And the derivative of the natural log of x is 1 over x. The derivative of x minus 1 is 1. So this is the limit as x approaches infinity. Well, 1 over x over 1 is just 1 over x. And it's clear that as x goes to infinity, 1 over x goes to 0. And that's my limit. So this is using L'Hopital's rule. We get the indeterminate case. We take the derivative of the top and bottom. We reevaluate. And this time we get a finite limit. If you get an indeterminate case again, you can use L'Hopital's rule twice in a row. 3 times in a row if you need to. So just kind of keep that in mind, but this is a pretty useful little tool for evaluating functions. That is a application of the derivative.